Hello, welcome back. It is lesson 1.6 today, which is all about discussions of the tides. So if you've ever been to the ocean, you'll know that you see that wet line in the sand where the water used to come up but no longer comes up, or it's still making that high point. Tides are the up and down of water as it's pulled on by the gravity of planets around us. And so we have to talk about which planet makes the biggest difference. We talked about two things that affect gravity the most, right? Mass and distance. So when we look at what makes the biggest difference here, it's actually going to be distance. So we'll see that both the moon and the sun are going to pull on the earth and the water on the earth to create the tides depending on where they are and how the earth is rotating. So in this case, the distance makes a bigger difference, and the moon will play a larger role in dictating the tides than the sun. There's two general terms that we can use in dictating what tide it is. That's going to be the high tide and the low tide. And what a high tide is the displacement or movement of water to a specific location caused by the pull of gravity. The low tide is caused because there's only so much water on the earth. And when some is pulled to the sides, it's condensed on the other parts. So you see this blue line here in which the high tide is on the outside, closer to the moon, because that gravity is pulling it that way. We discussed in another lecture about free body diagrams and how the reason we're not being pushed through the earth is because the earth is pushing back on us. The force that the moon has, pulling water one direction, is going to be equaled by a force going the opposite direction and pulling water that way. So it's a balance. Otherwise, all of the water would shift to one side and the earth would be thrown out of orbit. So you see with a standard setup that the moon would be here on the side, pulling the water, creating a high tide on each side, and a low tide on the top and bottom. There's two special cases that go along with just simple low and high tides, however. The first is called a spring tide. A spring tide happens when you have the sun, which will play a role here, the earth, and the moon all in a straight line. A straight line creates a spring tide. And when that happens, you have extra gravity acting on the same places. Before we just had the moon pulling water out, but now to go along with that, we have the moon pulling here and the sun pulling here. You see that? The moon is on one side, the sun is on the other, and they're both pulling water in the same directions. So if we look at the free body diagram, what we'll see is that the force created by the moon of gravity pulling water this way is reciprocated by a normal force that adds on to the gravity of the sun pulling in the same direction, which creates a force adding to the moon's. So you see that more water is pushed to those high tides. That means that for a spring tide, we have higher high tides and lower low tides. More water is pulled to these sides than in a normal situation. There's more gravity acting on the earth in this case, causing the water to be displaced. The less water there is on the low tides, the lower they will be. The last case that we have is called the neap tide, N-E-A-P. And what a neap tide shows us is that when the earth is in a 90-degree angle with both the moon and the sun, that we see a different pattern of tides occur. And what happens here, by looking at the free body diagram, is that we have the moon pulling up, or in whichever direction it is, being reciprocated by a force down. The sun, however, is pulling to one side or the other, and having another force that reciprocates out. That means we have all of our water being pushed in different directions because it's going up, down, left, and right instead of two big tides and two small tides. What we end up having is a very normal intermediate tide. Here we see that we have the lowest highs and the highest lows. Let me repeat that one more time. With neap tides, we have the lowest high tides and the highest low tides so that it's more uniform around the planet. The last thing that I want to talk about is that tides are always going to go in a cycle. And the idea of cycles is very important in this class and in other classes that you have. No matter what happens, you're going to see a shift from low tide to high tide and back to low tide. And this cycle will continue and continue throughout the phases of the moon, the sun, and the rotation of the earth.